as well as what is the important application of the rate of reaction. These all are we are completed. Okay, this now there is how many types of reactions are there? That is also completed. Yes, slow reactions, fast reactions, all are completed. Now we are going with our second concept, and what the factors are affecting our rate of reactions. That is only now we are going to discuss now. Okay. Yes, the page number 9. All the students, page number 9. Yes. Chemical analytics. The page number 9, we have the chemical kinetics concept. There is what we are going to discuss next. Factors of rate of reaction. Which factors affecting the rate of reaction? Which factors mainly already we are discussing. There is a different factors are there which are influenced our rate of reaction. Yes, what is the factors? Especially concentration of reactants and surface area of the reactants of molecule and catalyst, and also the temperature, pressure, and nature of reactant. These are the main components are okay. Reactant, whatever the rate of reaction is there, that is influenced by these the main components. What is the main components we are consider? Especially the first thing is about whatever the concentration of reactant. Okay, now concentration of reactant. You know very well what is the concentration. Okay, now there is a somewhat you have to know what is the dilution, what is the concentration, the difference between these two things. Okay, which one is called the concentration, which one is called the dilution. Suppose you take 100 ml of HCl. Here we are considered. Okay, now there is a whatever the 10 ml it will be there. Okay, now yes. In a particularly, we are taken what actually 100 ml of HCl in a 1 liter of water. In a 1 liter of water. I hope you got it here. 1 liter means what? 1000 ml of water. Okay, clear. And here I am taken one more combination of solution. There is I am taken 300 ml of HCl. And here I am taken there is what 1 liter water. Again, same. Which are contain a more concentrated in this. Okay, you know very. The 300 ml of HCl with the water, 1 liter of water is a contain a more concentration compared with the 100 ml of HCl with the 1 liter water. Okay, this is called 10% of HCl only. This is called 30% of HCl. Okay, now this is called a concentration. This process is only called a dilution. Okay, clear or not? It is a more diluted HCl. It is a less diluted HCl. Okay, clear or not on the students? We are using this type of words. What is the meaning of it? The meaning of that words are this is only when you take 100 ml of HCl and that will be combined with the 1 liter of water. That become what somewhat diluted when we are taken 30 ml. Then the diluted is 300 ml with the 1 liter. This is a become concentrated thing. This concentration of our reactants are influenced to the what? It is influenced to the chemical, okay na, reaction rate, chemical reaction rate, okay na, how it will be affected, that is important for us. How it is affected? Yes, the rate of reaction is directly proportional to the concentrated of reaction. Suppose we are taken the rate of reaction is like that, it is directly proportional to the concentration of the reactant. Got it or not? This is very, very important formula. Okay, for the finding of the rate of reaction. Okay, the question may ask on this particular problem only. The given rate of reaction or a concentration of our reactant. Okay, now yes, we have to require there is some particular relation. How we write the relation? R1 by R2 is equal to C1 by C2 all to the power of n. There is the two reactants are there. Okay, now the two reactants are yes have the relation in this particle in this mode. Okay, clear or not? The given two reactants and the reactant concentration is somewhat increases, somewhat decreases, and what is the rate of reaction? They may ask like that. Okay, clear or not? Here R is the what? Rate of reaction. C is the what? Concentration of the reactant. Yes, N is the we are taken as order of the reaction. There is, you know, very good. First order reactions, second order reaction, third order reaction. Then what is the order of the reaction? Okay, clear or not? Yes, that T is the main role played here. Okay, clear. The order of reaction and the concentration of the reaction both are main role played here. There is, you have to keep in your mind, R is a directly proportional to the C to the power of n. Okay, now here R is the constant. R is the what? Rate of reaction of a chemical reaction, rate of reaction of a chemicals, and as well as this is the concentration. N is the what? N is the order of reaction. Here, right now, here R is what? Rate of reaction, or is the rate of reaction. Yes, and C is concentration of reaction. Concentration of reaction. Yes, next. N is order of reaction. N is order of reaction. This is only the relation we are considered for the yes, how it is affect our rate of reaction. What you understood from this one? According to you, there is I am taken before that 100 ml of HCl and as well as 300 ml of HCl, which is the given more rate of reaction. When we are taking a 300 ml of HCl in a 1 liter of water, it will give the more reaction. Compare with the 100 ml of HCl with the 1 liter water. Got it? The reaction rate is increases with the concentration of the that particular our reactants. Got it? Yeah. Please note down this. As when we remove this directly proportional symbol, it is also written as R is equal to K into T plus C to the power of N. Here, what is this K here? The specific rate here. Specific rate. Already you know very well what is the specific rate. What is the specific rate? When we are taken a 1 gram of our substance, okay, now 1 gram of substance is produced the 1 gram of product, and what is its velocity of the reaction? Okay, clear or not? What is the fastness of the reaction? That is only called as what? A specific rate. Means what? For a second, you take a 1 second. For a 1 second, how many grams of reactants is converted into how many grams of products? Okay, that is only called what? A specific rate. Yes, specific rate. This is only called what? This is only called a specific rate. 1 gram of a substance, yes, which is taken as a reactant. We are taking it is under the reaction of 1 second. What the products may get? Okay, now how much products may get? That is only called what? Yes, a specific rate. Okay, now yes, that is also we are included final formula for us. Yes, based on a concentration, what is that? R is equal to K into Cl. These two are very important for us. Okay, now please note down it. Yeah, one more factor. The factors affecting the rate of reaction. This is about a concentration. Next, after this, you have the one more component. What is this? Surface area of a reactant of molecules. Next component is the what? Surface area of reactant. Surface area of a reactant molecule. Surface area of reactant molecule. Got it or not, all the students? When you take a surface area of reactant of molecule, automatically it is also affected the what actually our rate of reaction. How? There is a more surface area is there. Okay, the rate of reaction is the become fast. Okay, clear or not? All the students are there here now. There is a what? Larger is the surface area of reactant of molecule, higher is the rate of reaction. Got it or not? When you check it here, there is a simple concept only. These are, don't think it is not in our syllabus. It is in our syllabus only. Okay, now somewhat yes, chemical changes. These are a reaction about the chemical changes. You have a 7th lesson, art of molecules and other chemical reaction. That lesson only there is we have the different types of chemical reactions. In that one, somewhat slow reactions are there, somewhat fast reactions are there. You know very well, rusting of iron, it will be take a lot of time. Okay, clear or not? And as well as the formation of hydrogen by the HCl and the zinc combination within the fractions of seconds only it is started. Okay, clear or not? But there is a what that is called a slow reaction. This is called a fast reaction. But it is a single reaction only. By using these all the things like a surface area of reactant may increases. Okay, now our reaction rate or increases. The higher rate of reaction may get when there is a larger surface may get here. Got it or not? Yes, that is why only generally we are using the powders for the increasing the rate of reactions. We not take a limb or other we are not taken together the whatever the big element we are not taken. We are taken what a granules or as well as the powders like that it is. Got it or not? Yes, because of that there is a what a rate of reaction increases. Got it or not? I hope you got it here. There is a when we are taken an overall substance, we not get that much of easily the reaction rate here increases, and suddenly the changes are not appear for us. But when we take it is individually, okay, clear or not all the students? Individually, at that time the reaction rate may increases. Okay, clear or not? Suppose you have to take a chips. Okay, now you take a chips. How they prepare, they cut into pieces and as well as that it will be okay now. Yes, oven under the oil. Okay, now boiled under the oil, they become out of chips like that. Otherwise, you take some big potato. Okay, you put it inside it. It is also same reaction, na? There is any changes are there? The same potato you have to take and it will be pasted by somewhat what here? Okay, now any other salt water that all the things. Okay, you take it is into oil. That is not a boil. It is a boil, but it will take a lot of time. The same taste may get like a chips also. But when we cut it within the fractions of second only, that all under boil. Okay, now that will be looks like a chip. But that our whatever we are taken that total potato it look like a chips. No, got it. The same manner you applied for our okay na yes surface area reactant for a molecules also. Got my point or not? Here they given one example in our textbook. When you take a zinc wire, we not get the hydrogen instantaneously. We are take a much time for that get hydrogen within the HCl. Okay, clear or not? You know very well this reaction or not? Zinc is a combined with the HCl. It is a produce the what actually it is a produce the zinc chloride and as well as yes H2. There is a we are taken it is a 2 moles. Okay, we are taken 2 moles 2 HCl. Okay, got it? This is the reaction. It's a produce the hydrogen gas. In this one, I am taking this zinc particle as a what actually one line, otherwise a one wire. That is not given that much of easily the hydrogen gas. Okay, clear or not? Okay, now when we get the hydrogen gas quickly? Yeah, when we take a zinc is in the form of a powder, some small granules. Okay, at that time there will get the more. Okay, now yes, area, more surface area is available. That's why the more reactions are going on. Every individual surface is reacted with the reactant of HCl, and that will become what a pass in a reaction. The reaction completed in a pass within the small time only. Okay, how you can check it here? Suppose you take in our textbook they given. They given what like this surface. Okay, clear or not? Yes, understood or not? Now, when we take as a single surface, it is what happened here now? What happened? The length of this and as well as the width of this, it will become what a 3 into 3. Okay, now yes, the area become what a square. You know very well. It is a become what a 9 meters square for one surface of D. Every surface is a contain how much area here? 9 meters square. Okay, how many surfaces are get for it is 6 surfaces are get for it. Okay, 1, 2, 3, 4, 5. Okay, now another one inside of the yes 6 surfaces are there. Got it? Yes, these 6 surfaces are nothing but there is a 6 into 9. How many? 54 meters square it is there. Got it? Yeah, I want to cut this. Okay, now clear or not? The same thing. I want to cut it here into what? How many here? Half. Okay, clear or not? Totally, I am cutting all the directions into half. It is. Okay, how many is get it is now totally? Yes, there is a 8 things are get for us. Okay, now yes, I am cut it is into how many? Yes, like this it here. Okay, clear or not? And totally for one surface it is a 4, outer surface is a 4. Totally, one check it in your textbook. Like this it here. Got it? In second diagram, one check it. This is the first one. Okay, how much will we get? 9 meters square. In a second one, what it will be? It will be cut into what? 8 components are given. But half I am cutting, it is become 3 inches I am taken, somewhat meters I am taken, in our textbook inches they taken. 3 become totally become what? 1.5, 1.5. Okay, clear or not? All are become 1.5 and as well as the 1.5. How much area now? For a 1 lakh, for a 1 lakh, 1.5 into 1.5. It is a become what? 2.25 meters square. Got it or not? Yes. How many blacks are formed here? 8 blacks are formed. How many blacks are formed? 8 blacks. How many surfaces are there? Everything is a contain 6 surfaces and 6 into 8 into 2.25. Now the surface area increases or not? Okay, clear or not? The surface area, overall area is a constant, but individual surface area is increases or not? Okay, clear or not? All the student, just think it once, check it. I am taken. This is the duster. How many faces are there? This duster. There is. This is the one surface. Your side. My side is another surface. This is another surface. This is another surface. This is another surface. This is. How many? 6 or not? 1, 2. My side. 3, 4, 5, 6. Up and down. Side and side. Okay. Face to face. Totally 6. Okay. Now this is the criteria of this. I want to cut it totally. Cut into half. Okay, clear or not? Like this. I want to cut it here now. Okay, clear or not? Up to I am cut here and I am cut here also. How many pieces are get? 8 pieces are get, not 4. 8 pieces. I am cut in this particular area. I am cut in this particular area. I am cut in this particular area. Middle also. I am cut here first. Okay, now middle you cut it. What? 2. Okay, now I am cut here and here. 2 into 4, how much? 8. Okay, clear or not? 8 cubes are get for us. Everything again, I am taken a one small piece of it. It is a contain 8 faces, 6 faces or not? 6 faces are there. 6 into 8 into 2.25. Now what it is become? That become what actually 108. Okay, meter square will become. Okay, clear or not? Surface area increases or not? Surface area increases. Further you cut it. How many you'll get now? Yes, when you cut it is into, there is a 27 blacks may get when you cut again. Okay, now again 27 into 6 into, okay, now again there is a 1 on 1 into 1 meter only will. Okay, clear or not? At that time, totally when you cut it is into one more time, 162 meters square may get for you. 27 into 6. Okay, now yes, like that. There is a surface area is increases when we cut the material. When we cut the material, the surface area is increases. Yes, it is a more reaction is taken between one reactant to other reactant. Okay, one reactant to other reactant. Automatically, the rate of reaction is become larger. Okay, okay, clear or not, all the students? More surface area is available. Every part in the reactant is a reactant with the one reactant with another reactant. Okay, clear or not? Overall, one zinc nail you consider. Okay, only outer surface is only reacted initially. Okay, when it will be go inside the inside of the substance, it will be take some time. Okay, simple thing now. There is you have to take this chalk piece. Okay, now yes, don't go any other way. Okay, you take this chalk piece. It is now look like in a one surface only. You take this chalk piece in a one particularly, okay, in a one particular water. Okay, clear or not? And you take the same thing, it is in a powder form. Which one is melt earlier? Okay, I am taking here in this particularly. Already have it here, one experiment with me. Okay, now there is it is a container what actually as a one surface only. This is actually lime. Okay, it is a one surface only. It is a lime, not a chalk piece. It is lime. Okay, now I am taken here as a one single thing. I am taken. There is a one more thing here. Check it. Okay, I make it is into powder. Okay, clear or not? I take it is into powder form. Okay, check it here. Okay, totally it is powder only. Okay, got it? Yeah. I am taken here now lime water. Both is the same, but I am taken the water into the same thing. Okay, clear? Yes. Once check it on the students. It is already, it is a powder. It is a bottom. Once check it. One thing only there here. Got it? It is a bottom. As a single thing only there. Here there is a what? We have powder. At the bottom one check it. Powder only there. The bottom one check it here. It is a surface. Only one surface contains. Now more surfaces are there here. More surfaces are there. Yeah. Now I am taken the as whatever the once I want to stir it. Okay, clear? Now I want to shade like that. I want to like this. Once check it already here there is a what happened. There is a no change appear in this, but there is a somewhat changes are appear. It is a become as a lime water now. Okay, it is not a till now it is not become as a lime water. May it will be concentrated, more concentrated, but today it is not completed. Okay, once I want to check it here. Okay, by the phenolphthalein, okay, solution. By the phenolphthalein solution, once check it at the same time. It become as a pink color now. Once check it, it is not a become pink color. Now the reactions have started already. The rate of reaction is going on fast. The same material I am taken in front of you only, but when I am stirred it, okay, it will be till not it will be completed its reaction. Same material I am taken, once check it in front of us only. Okay, it will be totally become a pink color, but it is not become a pink color. I am taken the same reactants, but it is in powder format. It is not in a powder form. Okay, this is only the rate of reactions. Okay, now when we take a surface, more surface area, it will be gives a what? Fast reaction. Got it? Yes, less surface area is gives a less reactivity. Got it? This is about totally concept of rate of reaction. Got it? Yes, and next thing is the catalysts. Okay, now actually you have to know somewhat about the catalysts. Catalysts are nothing but what actually they are not directly involved in the chemical reactions. Okay, but they affect the chemical reaction. Okay, now yes, in a photosynthesis reaction, the sunlight is a catalyst actually. Got it? Or in a photosynthesis reaction, sunlight is a catalyst. You know very well nowadays. Okay, whatever the greenhouses. Okay, now they constructed. The farmers have constructed greenhouses. Okay, or otherwise it is called polyhouses. In the polyhouses, there is a more productivity may get in a cultivation process. Why there is a more productivity may get? Yeah, there is a most of the time there is a whatever the sun rays are there, they are available in that polyhouses. Compare with the normal nature. Okay, that is only called greenhouse effect in a normal nature. Normally, actually, in a greenhouse effect is a harmonics for our regular life, but it is a good for the what? Good for the which one? It is a good for as plants, not heavy as whatever the subsequently it will be good. Why? Because more photosynthesis reaction is going on because of at the night also contains somewhat temperature. Okay, na, which is holded by the polyhouses. Okay, otherwise you take a yeast powder. Okay, when you want to prepare a curd, okay, na, it will be take about 6 to 7 okay na, hours. But when we add the yeast to it, there is a no change in the taste of the curd, but immediately that will become as a curd. Okay, clear or not? That is called catalyst. Catalyst is not involved any chemical reaction. It is not produced any products in a chemical reaction, but it is increases the rate of reaction. It is increases the rate of reaction. When we are used the catalyst, the rate of reaction is increases. Okay, clear or not? This is only about the concept of what factors affecting the rate of reactions. Tomorrow we'll go with the remaining rate of reactions. Okay, now all the students, please keep in your mind. Okay, this lecture 2, whatever there, it will be coming in your upcoming examination of IIT. Okay, now lecture 2, only lecture 2. Why? Because we not take much classes in a chemistry. Okay, now why? Because it is a big lesson is there in our physics first lesson, sorry, second lesson. Okay, that is why I'm not taken much classes. We want to complete this lesson, then after again we go to the two-dimensional motion of physics. Okay, thank you. Bye, take care. Any doubts from any branches? Any doubts from any branches? Thank you.